quadratic number patterns, in grade 11 you added that to the linear number patterns. In these quadratic number patterns, there is a recipe. What do? First of all, know that it's a number pattern. I don't think you would have not thought that this was a number pattern if I said, there we go. Find the general term, or find the rule, the general rule, or whichever way we ask it. And now, we always do this in maths, because maths is full of patterns. And those patterns make up graphs, straight line graphs, quadratic graphs, which are parabolas, exponential graphs. Are you with me? All the patterns make up graphs as well. So all of them work together. Now in these number patterns, when you start off and you thought that this might have been a linear one, you would have found out by doing the first difference, which you don't have to write there. You would have said, tell me, 14 minus 20. Please do it that way, so that when you come to x's and stuff, you'll do the same thing. Second minus the first, 10 minus 4, 8 minus 10. You with me? It's not the same. That means that this is not linear. This is not a linear pattern. If it's not linear, then let's try and see if it is quadratic, because if the second difference is the same, then it's quadratic. Now again we say second minus the first. Now minus 4 minus minus becomes a plus. So it's minus 4 plus 6, that gives me. And if you struggle with that, please do it on the calculator. But again, if it was x's and y's, you've got to know that it's that number minus that one. So minus and minus is going to become a plus. Minus 4 plus 6. This is going to be minus 2 minus minus becoming a plus 4 again is 2, that you don't by accident have negative 2 here. Careful. Alright, it's easy, but be careful. Then you were taught 3 formulas, namely 2a. That's my first formula. We work backwards here. My second formula is
3a plus b.
3a plus b equal to whatever standing there. Third step,
a plus b plus c.
whatever's in the first place. That's the recipe. So then our steps are exactly what we've written there. Step number 1 is where 2a is equal to 2, so we say that a is equal to 1. Then we go to step number 2, where we've got 3a plus b equal to negative 6. Now we know that a was 1. Now you can have less steps, it's fine. But positive 3 will become negative 3, and b is equal to negative 9. Then our third step is a plus b plus c is equal to 20. A was 1, b was negative 9. That means that c will be 28. What was the question? Find the general term. I've done all the work, I just haven't written the answer. The general term of a quadratic number pattern is a(n) squared, which is 1n squared, plus bn minus n, and then plus c plus 28. Do you need to write a(n) squared plus bn plus c first? It's always a good idea, but it won't be worth a mark as such. But then I know you're on the right track if you're not working with a linear one. Okay, for future reference, future very soon, this first difference row is what type of a row? This first difference row, if you close that first bit there, you are busy with a linear pattern. You see it? Close this up. And now we have a linear number pattern. Will that always happen, in other words? Yeah. In a quadratic number pattern, the first differences form a linear number pattern, of which this is the difference in the linear number pattern. Do you see it? Because they're going to ask you, look at the first differences, it forms a pattern, get me that one's general term. So what do? To find that one's general term. Grade 8, 9, and 10 work. Where your a(n) plus b, the a is to find the b. Are you with me, guys? Can you see how they're going to combine it? Will it always happen? Yes, always. If it is quadratic, with a constant second difference, then the first difference row will also be a linear number, always. Okay, did you get that right? Good. So for our second one, we go and we look at this and we say 6, 7, 5, 10. Oh my goodness, what's happening here? Don't look at it like that. Let's go and see. First differences are 1. Okay, that one is 1. Minus 2. And they didn't give, I would have loved them to have given me a little bit more. Because if I just say to you, there's the pattern, go find me the general term. And I feel a little bit uneasy to say already that this is definitely a quadratic one. Because if it's quadratic now, this has to be the same second difference, which is minus 2, minus 1, minus 5. Minus minus becomes a plus, which also gives me negative. I like it if there's a little bit more proof. If there was a third and a fourth one that I could double check. Okay, sometimes they could even give you less. But then they will definitely say, this is a quadratic number pattern. Find whatever you're looking for. So if I say it's quadratic and you could only find that piece there, then you know that that is your A part. 3a plus b, a plus b plus c, because they said so. If you just have to look at it and decide for yourself, is it linear, is it quadratic, then this wasn't enough. Because you can't see that a constant second difference is there. Are you with me what I'm aiming for here? Right, my steps are, step 1, formula 2a. Second step, 3a plus b. And nobody's forgetting that today, am I right? A plus b plus c. Alright, so we do the steps as they come there. 2a is equal to negative 3, meaning that a is equal to. For some reason you felt it yourself. You like it when it's 1 and 9, minus, it's fine. But if it's fractions, you immediately feel, don't. We like fractions. Fractions are part of maths. Okay. Number 2. 3a plus b is equal to 1. So we substitute our a with negative 3 over 2. Okay. You don't have to show me the steps. That will become negative 9 over 2, which will become plus 9 over 2, which is 4.5. Plus the one is 5.5. So whether you write 5.5 or 11 over 2, and please do it with your calculator. Stress is a serious thing. When you're sitting there in stress, then all the stuff you do in your head becomes wrong sometimes. Do it on the calculator. Time it, take the one across, say 1 plus whatever, get the answer. Is it fine if you wrote 5.5? Even 5,5? It's not going to look so nice if there's a comma and a fraction all in one sum. We don't like that. We like it all to be fractions or all to be decimal fractions, but it's fine any which way. Number 3, a plus b plus c is equal to the first number there, which was 6. The a was negative 3 over 2 plus 11 over 2. And because I left it in that fraction form, it's easy for me to do it without the calculator, because that'll be minus 3 and plus 11 giving me 8 over 2, which is 4. We're just testing our brain a little bit. 4 minus on the other side, so C will be 2. Please use your calculator. Time with, add with your calculator, subtract with your calculator, you can't go wrong. Please practice your brain at home, but in a test, you use your calculator. Even if stress comes and you say 1 plus 1 on the calculator. I'll stand there and say, but okay, you're going to get it right. So the general term is, to answer the question, A was negative 3 over 2 n squared. B was 11 over 2. And C was 2. And again, with all the variations of writing it. Could I write this as 11n all over 2? Okay. 5 comma 5 n. All of that stuff. Normally we write the coefficient in the front. Right, let's do another one, same thing. So first of all, that little first PC that we've got to run through now because it's easy. We're going to do first differences, and that is -6 because we say -5 minus 1. Minus 13 minus becomes a plus, so it's -8. Minus 23 minus becoming a plus, so it's -10. And when this doesn't want to work out, it's not the sum that doesn't want to work out. Just go check yourself that you didn't do this wrong. Because then if you did this wrong, then this won't work out to be the same constant. Second difference. Check up on yourself. Do a double. So this is going to be -2. Do we agree that it's -2? Okay. Minus 8 plus 6. Minus 10 plus. Because of minus times a minus and then plus. Definitely this is quadratic, so let's run through it. 2a is 3a plus b is a plus b plus c is step 1, 2, 3. You can't say 1, 2, 3. This is, in any case, if you don't write this, it's fine, as long as you just do 2a equal to -2 first. Because in that equation, there's only one variable to solve it. And once you have it, -1, are we agree? Then we can get to the second one, because now 3a plus b has 2 variables, but I have a, so then I only have 1. So it's going to be 3 times -1, giving me -3 becoming a +3, so the answer is -3. Double check yourself. Don't go too fast and make mistakes on easy marks. A plus b plus c is equal to 1 in this case, the first one. So it will be -1, -3 plus c is equal to 1, and c is equal to 5. Double check yourself. -4 becoming a +4, and it is 5. So my general term, I didn't even read you the question, we know it's going to be the question. General term is going to be -1 n squared, -3 n +5. If you have time, which you normally don't in a test, quickly go check yourself. Put a 1 in the place of n, do your substitution summary, it has to work out to 1. If you put in a 2, it has to work out to -5. And if you've tested 2, you should be fine. If you do the stuff properly and meticulously, you shouldn't make mistakes. Don't rush through it, then you make mistakes. Okay, you have to work fast, but don't rush. Okay, now that was the first part of the question. The second part of this question was find which term in this row, I can just find it myself, which term in this row will be equal to -643. What must be equal to -643? Which term? So what do I put there? This formula. Do I put 643 in the place of n? Okay, are you with me? That's the two things that can happen, like I showed you in the normal linear one yesterday. You can either put the number in there, but that also doesn't make sense, because how can n be negative? Are you with me? N cannot be negative, but can a term be negative? Alright, so we've got this formula, -n squared minus 3n plus 5 equal to -643. So, we have a quadratic equation, rules. Equal to 0, guys, this is your toolbox. Equations, if it's quadratic, either equal to 0 factorized. If it can't factorize, formula. Are you with me? Those are your tools. So for this sum, let's do it this way. Agreed with ma'am? Because you can do whatever you like. I chose this option of taking everything to the right hand side because first of all, when you finish, that n squared before you start factorizing has to be positive. So if you left it on the left-hand side, you had to either divide by the negative again or something like that. Alright. Now, we have to go get our factors. If you cannot get the factors, why would you think we're going to struggle with factors here?
It's a big number.
Because it's such a big number. So even if it does have factors, go for the formula. Then you cannot make a mistake. Some kids do the formula all the time. It takes too long if you want to do that every single time, because you have like 20 quadratic terms to factorize in an exam. There's not enough time to do every one of them with the formula. You go to the formula. Right. So in the formula then, okay. I'm sure this thing has factors because I know it has to have, because n has to be a natural number when I'm finished. This answer has to be something like 7 or 8 or whatever. And it can't be a fraction, because then position number 8.5 won't work. You with me? Oh, sorry, I'm here. Thank you. Yeah, it is 6 or 8. Must be there. This is the equation I'm trying to solve. This is the equation I'm trying to solve. So the A is 1, the B is 3. This is my equation I'm trying to solve, not the original one. Alright, so what my answers are, please?
24.
Yeah.
27. Or negative 27.
Thank you. Now, could it be two answers? There could be, because remember this is a parabola. It could be something like this, and I'm asking when this answer is going to be equal to negative 6, 4, 3, and it can happen twice. And it did. But now we're looking at the practical side of it. This is a quadratic number pattern, so I'm asking you which number in the pattern. So it can be the 24th one, but there's the negative 27th one. So that will not be. And that's all you need to do. Or you can say not applicable, or say the only solution is 24, whatever you'd like to do. But the 24th one would be equal to that. So if you actually had time to go and keep on doing this for the next term, what would be the next term here? You'll have to say minus 12 and get to negative 35. And for the next one, you'd have to say negative. Are you with me here with the pattern? Because we haven't done it here. But the first question normally is, what are the next two terms? So you've got to keep going with this pattern. So that would be negative 4. Are you with me? Nice, easy 2 marks, if they asked you that. So the numbers can get you negative, and largely negative, but the position number cannot be a negative. Right. Happy on that one? Now I'm going to ask you to find the general term, or find the rule for the pattern of the first differences, what we spoke about earlier. What am I asking? Find me the rule for the pattern of the first differences. It's a sum on its own. It's that negative 6, negative 8, negative 10, and I've got to get the general rule, which is, are you with me here? Okay. Do not use grade 12 work, even if your extra math teacher tells you to. You're not allowed to in grade 11. Okay, you're going to get a new one in grade 12, but you're not allowed to use it in grade 10 or 11. So, first of all, that A is, let's really write it here, negative 2n plus the B. Like we said yesterday, now we're busy with grade 10 work here, 8, 9, 10. How do we find the B then? Term 1 would be then negative 2 times 1 plus b, and that must be equal to? What must term 1 be equal to? Are you sure it's negative 6 and not 1? You must be with the correct pattern, right? In this pattern, the first one is, so we've got b is equal to negative 2 becomes a positive 2, negative 4, so the general term is 2n minus 4. That's way too much steps. I just need the A, and then I need the C. So basically I just need the answer for 2 marks. But that's how they can incorporate grade 10 or linear ones inside of these ones as well. Right, I want you to do for me. On page 45, number C and number F.